Hi, in this lesson, we go into more details related to triggers. In the previous lesson, we understood what are the applications of trigger, how to create a before trigger or after trigger, and the difference between statement level and row level trigger. Now, let us start with a different kind of trigger called instead of trigger. A before trigger is executed before the DML command is executed. After trigger is executed after the DML command is completed. But instead of trigger is used to execute some commands instead of the actual command. That means it does not execute the given DML command. Instead of the actual DML command, it executes the trigger. So this can be created only on views, not on tables. And it is used on views where we cannot directly manipulate view. If you can recollect from our discussion earlier about views, not all views are updatable. There are views that cannot be manipulated. That means they cannot manipulate base tables because they don't satisfy the rules related to making a view updatable. We see an example here, and this is a view called employee job, which is taking data from two tables. Generally, when a view is based on multiple tables, it becomes read only. And this view is taking data from employees and jobs. And also in the context of join views, the views that are based on join, we can manipulate only the key preserved table. Key preserved table is the table whose primary key is still unique in the view. So if you take this particular example, employees and jobs are the base tables, and employees table's primary key, that is employee ID, is still unique here. But job ID, which is the primary key of a jobs table, is no longer unique because there might be multiple employees belonging to the same job. So job ID is repeated in this view. So we can say employees is the key preserved table for employee job, and jobs is not a key preserved table. So in this context, if I try to update any column of employees table, like first name, for example, that's fine because you can update a key preserved table. But if I try to update a job title, which is coming from non-key preserved table, because jobs is not a key preserved table, Oracle throws an error. And you can see that clearly here. I'm trying to update a job title, which is coming from jobs, and I'm using my view, employee job. And that throws an error, and the message very clearly says, you cannot modify a column that is related to non-key preserved table. In this case, jobs. So what is the remedy for this? I want to update a job title using employee job view. So if you want to update a column in non-key preserved table, then you need to go for instead of trigger. So this is the scenario. Our view is based on two tables, but employees is the key preserved table. So I can make changes to that through the view, but I can't make changes to jobs because that is not key preserved table. The solution to this is creating an instead of trigger. So create an instead of trigger on employee job, because instead of triggers can be created on views. And then I'm trying to bypass the actual command. So I'm not going to execute the original update command. For example, this is the original update command, and we don't want this to be executed. Whenever you give this command, we want Oracle to execute this block, and that is our instead of trigger. When this block is executed, there I want to update employees table, change the first name to new first name, and I want to change jobs table and set the job title to new job title. So normally you cannot update jobs table using this view, but with the help of instead of trigger on employee job, I'm able to update both employee's first name and the job title. Job title is not updatable otherwise, but with the help of instead of trigger, we are able to do that. So this is the application of instead of trigger. So if you create the trigger and give this command, it works. But if you try to do the same without creating any instead of trigger, then you get the error saying cannot modify the column which is related to non-key preserved table. So instead of triggers are quite different from normal triggers. We have seen before and after triggers before, but those two were executed before and after the actual DML command respectively. But instead of trigger is executed bypassing the actual DML command. So pretty powerful, but it's only in the context of views. Then at times, when we have a single trigger fired for multiple DML commands, let us say I have a trigger which is executed both in case of insert and update. And then I want to know whether the trigger is fired because of inserting or because of updating. Well, that's the reason why Oracle is providing 3 keywords which you can use in the context of your trigger. So inside the trigger, if you say inserting, it returns true if the trigger is fired because of insert command. And it returns true if you are executing update command and your trigger is fired because of update command for updating keyword. And deleting keyword will return true if the trigger is fired because of delete. Let's talk about an example related to inserting, updating, and deleting. I want to create a trigger that is going to log all the changes you make to employees table. So whenever you're trying to insert a row, I want to write into employees log with employee ID. And remember, for insertion, we have only new ID, no old ID. So we use new and we put the system date and time and I assume there is a table called employees log with 3 columns, employee ID, date and time, and then the kind of operation. So that's going to be I in case of insertion. If it is not insertion, if the trigger is fired because of we updating employees table, then this is true and we are going to put U as the operation. And we again use the employee ID and sysdate. And here you can use either new or old because update is providing both correlation names. But when it comes to the last one, we are trying to put D and we must use old because we don't have any new employee ID when we are dealing with deletion. So you have to be careful about the correlation names because the operations dictate what correlation names are available to us. So this is an example for inserting, updating, and deleting keywords which are used to know whether the operation is insert or update or delete. Now, there might be cases where you want to delete a trigger altogether because it's no longer relevant. But there might be also cases where your intention is not to drop the trigger altogether, but only to disable it for the time being. Why? Why do I disable a trigger? Well, you disable the trigger because you strongly feel in the current context the trigger need not be executed. If you feel the trigger need not be executed because the changes you are about to make are all valid changes, no need for trigger to verify the changes. Then you can disable trigger to improve performance. It's all about performance, because if I'm trying to change something like thousands of rows, I don't want the trigger to be fired and a lot of time is spent on executing trigger for each row. So I would like to disable the trigger. Before I execute a command like this, which is changing the first name, and I'm just changing the first name to init cap. That means every first letter of the word is in uppercase, remaining in lowercase. This is not an operation that could inject any invalid data. So before I do this, I want to disable the triggers related to employees tables updation. Well, in such a case, you just need to go and use disable option, either with alter trigger. In that case, you give explicitly a particular trigger name, or you can disable all the triggers related to a table. When you say alter table employees, disable all triggers are disabled. Anytime later, you can re-enable all the triggers. And if you want a single trigger to be disabled, just give the trigger name disable and perform whatever operations you want to perform. And again, you can re-enable the trigger. Of course, you got to be the owner of the trigger to do that, not somebody else. So this is how you can disable and enable triggers depending on your requirement. Of course, if you want to drop the trigger because you feel the business rule that you mentioned in the trigger is no longer applicable. For example, we didn't want anyone to make changes on Sunday, but for some reasons that is no longer relevant, we can drop the trigger altogether. Then, in the recent past, we got a very powerful kind of trigger called compound trigger. This is one trigger that can perform 4 different actions at 4 different events, like before row, before statement, after row, after statement. Actually, this would need 4 different triggers. In olden days, if you had to create a trigger for before row level and then before statement, you would have to have 2 different triggers. The problem with the 2 different triggers, they are 2 different PL SQL blocks. So if I have to access some data that is common to these 2, it was difficult. So compound trigger is saying I put all of them in one PL SQL block. So the before row level, before statement, and after row level and after statement, we are going to put all these 4 in one block, and then there you can have some data also if you like. And the advantage is all these blocks get access to this data. So it's one PL SQL block with 4 different subblocks, and all of them are having access to some variables. So this is ideal for implementing some complex business logic. This is called compound trigger. It's one trigger with 4 different subblocks, and one for before row, one for after row, and one for before statement, and the last one for after statement. So where do we use this? Do we need this in any case? Let us see a use case here. Well, this is the syntax for that. You just need to give compound trigger, and that makes it a compound trigger. And here are the declarations, and these are the blocks: first block and second block and third and fourth. These blocks can have the code, and all these blocks can also access the data that you declare here. All the variables that are there that are declared here can be accessed from anywhere. Now here is my use case. I don't want to increase the salary of employees by more than 10,000 in a single update command. So in a single change, I don't want to exceed the total hike of 10,000. How do I do that? Because this is difficult if you have to go without compound trigger. But compound trigger made it simple. So here we are. We create a variable called total. And this total variable is set to 0 in before statement trigger. So before the statement, the update statement is executed, total is 0. And then before each row, I have nothing to do. If there is nothing to be done in a particular subblock, you can just ignore it, but you have to give null. Without that, it is invalid. You can't leave any block totally empty. So you can just give null statement. Then what? In after row, you see, after each row, we want to take the difference between the new salary and old salary, and that is added to total and put into the total variable. So this is where we are adding the hike to total. And now comes the last one, the after statement. This is where I want to know whether the total is exceeding 10,000. If so, I throw an error and stop the process. So I'm saying total hike in salary cannot cross 10,000. So this is the use case where you can apply compound trigger, because if you want to do the same thing without a compound trigger, it would be, I don't say impossible, but would be much more difficult than this. Now let us see how we can apply this. And here is my compound trigger. I'm trying to make some change, and here if I try to make a change like this, so is this single update command in which we are increasing the total salary of all the employees by more than 10,000? Of course, because we are going with first 10 employees, and we are increasing the salary of each employee by 2,000. So obviously the total hike is going to exceed 10,000. But without a trigger, this will go ahead and it is updating 10 rows. But now I need to go and roll back that because I don't mean to make such a change. Done. And now let's create the trigger. If I create the trigger successfully, and if I now go and execute this, it's trying to increase the salary of each employee by 2,000, and it is updating 10 employees' salary. That's going to be 20,000. But that's bigger than what we can allow, because we can allow only 10,000. So this is going to be aborted because the trigger fails. Go ahead, try. There we are. So total hike in salary cannot cross 10,000. That is the message, and this change is aborted. That means the compound trigger is what is failing, and as a result, the whole operation is aborted. So compound triggers can play very important role, relatively advanced, but you may need it in some specific cases. So that's about the compound trigger instead of trigger. So this is where we talked about how to raise the salary by 500. That's okay, because 500 is not going to cross the 10,000 threshold we set. But if you try to increase salary by 2,000 for 10 employees, it's going to cross that. So this is how you can test it. This is allowed, this is valid, but this is not allowed because this is crossing the limit. So in this lesson, we started with instead of trigger. Instead of trigger is used only with views, specifically the views which are not allowing you to update base tables. You can overcome that limitation by using instead of triggers. Then you can know whether the trigger is fired because of inserting or updating or deleting using those keywords. Anytime you can enable or disable a trigger, you have to decide whether to disable or not to improve performance in some cases. If you want, you can. Anytime you can re-enable it. Drop a trigger if it is not making sense anymore. And compound trigger is one trigger with four events: before row, before statement, after row, after statement. And we have seen how we can use it in order to prevent a change to salaries in such a way the total hike is crossing 10,000. So this is about triggers, and we have seen it in two parts because triggers are pretty important to maintain integrity of data. That's all for now. See you in the next lesson.